children, I am Shishmita and welcome back. Previously, you have learned about charge, electric current, electric circuit and electric potential difference. Now, without getting late, let us gather some information on Ohm's law and resistance. Learning outcomes. At the end of this session, you will be able to understand about Ohm's law, resistance of a material, variable resistance, factors on which the resistance of a conductor depends upon. Keywords: Ohm's law, potential difference, current, resistance, a measure of the opposition to current flow in a circuit, resistor, an electrical component that limits or regulates the flow of electrical current in a circuit. Variable resistance, a resistor of which the electrical resistance value can be adjusted. Resistivity, the extent to which a material opposes the flow of electrical current through it. A German physicist, George Simon Ohm, established the relation between the potential difference and current, which is known as Ohm's law. This relationship can be understood from an activity. Set up a circuit consisting of a nichrome wire XY of length, say 0.5 m, an ammeter, a voltmeter, and 4 cells of 1.5 V each. First, use only one cell as the source in the circuit. Note, the reading in the ammeter I for the current and reading of the voltmeter V for the potential difference across the nichrome wire XY in the circuit. Next, connect two cells in the circuit and note the respective readings of the ammeter and voltmeter. Repeat the above steps using 3 cells and then 4 cells in the circuit separately. Calculate the ratio of V to I for each pair of potential difference V and current. We will find that approximately the same value for V by I is obtained in each case. Thus, the VI graph is a straight line that passes through the origin of the graph. Thus, V by I is a constant ratio. The potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. This is called Ohm's law. V directly proportional to I, V by I is equal to constant, V by I is equal to R, or V is equal to IR. Here, R is a constant for a given material at a given temperature and is known as the resistance of the material. Resistance of material is its property to oppose the flow of charges and hence the passage of current through it. It is different for different materials. Certain components offer an easy path for the flow of electric current while others resist the flow. We know that the motion of electrons in an electric circuit constitutes an electric current. The electrons, however, are not completely free to move within a conductor. They are restrained by the attraction of the atoms among which they move. Thus, the motion of electrons through a conductor is retarded by its resistance. A component that offers a low resistance is a good conductor. A component that offers a high resistance is a poor conductor. An insulator offers very high resistance. The material that offers resistance to the motion of electrons is called a resistor. From Ohm's law, R is equal to V by I. The resistance of a conductor can be defined as the ratio between the potential difference across the ends of the conductor and the current flowing through it. The SI unit of resistance is ohm and it is represented by the symbol omega. Resistance of a conductor is said to be a 1 ohm if a current of 1 ampere flows through it. When a potential difference of 1 volt is maintained across its ends, 1 ohm is equal to 1 volt by 1 ampere. We can also write I is equal to V by R. It is obvious from the equation that the current through a resistor is inversely proportional to its resistance. If the resistance is doubled, the current gets halved. In many practical cases, it is necessary to increase or decrease the current in an electric circuit. A component used to regulate current without changing the voltage source is called variable resistance. In an electric circuit, a device called a rheostat is often used to change the resistance in the circuit. To understand the concept of the factors on which the resistance of a conductor depends, let us do an activity. Construct an electric circuit consisting of a cell, an ammeter, a key, and anichrome wire of length L. Now plug the key. Note the current in the ammeter. Replace the nichrome wire with another nichrome wire of the same thickness but twice the length, that is 2 into length. We note that the ammeter reading decreases to 1/2 when the length of the wire is doubled. Now, replace the wire with a thicker nichrome wire of the same length L. A thicker wire has a larger cross-sectional area. We note that the ammeter reading increases when a thicker wire of the same material and length is used in the circuit. Instead of nichrome wire, connect a copper wire to the circuit. Let the wire be of the same length and same area of cross section as that of the first nichrome wire. We note that the ammeter reading changes when a wire of different material of the same length and the same area of cross section is used. On applying Ohm's law, we observe that the resistance of the conductor depends on its length, on its area of cross section, on the nature of its material. Precise measurements have shown that the resistance of a uniform metallic conductor is directly proportional to its length L and inversely proportional to the area of cross section A. That is, R directly proportional to L and R directly proportional to 1 by A, combining both the equations, R directly proportional to L by A, R is equal to rho L by A, where rho is a constant of proportionality and is called the electrical resistivity of the material of the conductor. Electrical resistivity of a conductor is a measure of the resisting power of a specified material to the passage of an electric current. It is a constant for a given material. The SI unit of resistivity is ohm meter. The metals and alloys have very low resistivity in the range of 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. They are good conductors of electricity. The resistivity of an alloy is generally higher than that of its constituent metals. Insulators like rubber and glass have a resistivity of the order of 10 to the power 12 to 10 to the power 17 ohm meter. Both the resistance and resistivity of a material vary with temperature. Points to remember. Ohm's law. The potential difference across the ends of a resistor is directly proportional to the current through it, provided its temperature remains the same. Resistance is a property that resists the flow of electrons in a conductor. It controls the magnitude of the current. The SI unit of resistance is ohm. A component used to regulate current without changing the voltage source is called variable resistance. The resistance of a conductor depends directly on its length, inversely on its area of cross section, and also on the material of the conductor. The metals and alloys have very low resistivity in the range of 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. Insulators like rubber and glass have a resistivity of the order of 10 to the power 12 to 10 to the power 17 ohm meter.